Hi guys, so this is lesson 5.2. Okay, so 5.2 is called More Max and Min Applications off of section 5.1. So this is just going to be slightly more complicated as far as finding max and mins. You can't just always do it algebraically. You'll actually need calculus in order to do this because they'll give you more, slightly more complicated things to deal with. Okay, so there's actually only one example for this entire section. So hopefully this will give us enough information for us to be successful here. All right, so the first thing we're going to do is come up with the equation for the first sentence. So it says the sum of two non-negative numbers is 30. Okay, so if we've got x and y, let's just say, they're going to add to 30. Okay, and so immediately it's important for you to say that they have to be non-negative, and basically you also know that neither x nor y can be greater than or equal to 30. Well, I guess they could be equal to 30 because you could have 0 and 30. So we want to say 0 is less than or equal to x is less than or equal to y. No, excuse me, is equal to 30. Okay, so that's basically the restrictions for the x value, and then the y would have the same exact restriction. Okay, so it can only exist between 0 and 30 just from that first statement. Okay, from the second statement, find both numbers if the sum, so I'm going to use s to represent sum, of twice the first, so 2 times the x, plus the square of the second. So x, oh, excuse me, the second is going to be y. So y squared. Okay, and it's important that this is read as a maximum. Okay, so we'll get to the maximum piece at the very end. Okay, so we're going to start this exactly like we did in the last section. We're going to solve for one of the variables and then plug it into our maximum piece. So I am going to go ahead and solve for the y. So I'll just say that y is equal to 30 minus x. So I'll go back to this equation, and when I get to my 30, or excuse me, my y, I'm going to replace it with 30 minus x. Okay, so just be aware also that you absolutely could have solved for x and replaced the x piece. Okay, so either way works. Maybe this is a little bit more complicated because I have a quantity that's squared, so I'm going to have to simplify this in order to derive it. So if I square this and FOIL it out, I would get 900 minus 60x plus x squared. So then if I basically make that in a standard form, I want my x squared first. I have 2 minus 60, so that's going to be minus 58x, and that's going to be plus 900. Okay, so there's my sum formula. Okay, so my next step now is going to be to derive that so I can figure out the critical values for a possible maximum. So if I derive x squared, that makes 2x. Derivative of negative 58x is negative 58, and 900 would go away. So to find critical values, you set those equal to 0, and then we solve that. So I would add 58, divide by 2. So we get an x value of 29. Okay, so at this point, this becomes really important for you to draw this number line. Okay, so we have 0 to 30, remember. Okay, it can't go beyond those two values, and then we got 29 in the middle here. Okay, so we want to do our little sign test. Okay, so if I plug in a value between 0 and 29, let's just say 1. That would be 2 minus 58, which makes a negative number. And if I plug in a number between 29 and 30, like 29.5, you'd get a positive number. Okay, so at this point, I would go down and go up here, and so hopefully you notice that this looks like a minimum value, okay, to this scenario. So what I'm going to do is I'm going to test my critical values and kind of my range here, my domain, and see which one would give me the biggest sum. Okay, so now what I'm doing is going back to my sum formula and plugging in an x value of 0, 29, and 30. Okay, so let's say if I plug in 0, I would get, and I want to use this one where we're just have one variable, so I'd have 2 times 0 plus 30 minus 0 squared. Okay, so that would end up giving me, let's see, we get 0 plus 30, and 30 squared would give you 900. That seems pretty big. Okay, then I'm also going to do 29, because that was one of my critical values. (30 minus 29 squared). So let's see, 29 times 2 is 58, and then we're going to have plus 1, so it's going to give us 59. Okay, and then if I do up 30, 2 times 30, 30 squared, that makes 60 plus 0, so 60. Okay, so which one gives you your maximum? Okay, and so I think that's pretty clear that 900 is by far the biggest. Okay, with an x value of 0. So we would say the x would be 0, and then if I go back to my green equation to find the y value, that would make my y value 30. So 0 plus 30 is 30, and then the sum of the first plus twice the second will give you a max of 900 there. Okay, so that is the slight difference in this section versus the last section. Okay, you're going to have to use those critical values and the endpoints, those domain restrictions. Okay, so what I'd like for you to do is I would like for you to complete 1 through 9. Okay, and that will be due the next time I see you. Okay, so don't forget to do that.